Next, let's see how we can test a null hypothesis for no difference between two proportions. So we're testing here, are these two things different? Therefore, we want to set up our H0, or our null hypothesis, as no difference. That is, we want H0 to be that P1, or P hat 1, minus P hat 2 equals 0. So this is our total population parameter. We're expecting that there's no difference between these two populations. This means that we are usually going to set up an alternative hypothesis, means that P1 minus P2 is not equal to 0. So note that this can be in either direction. Because we believe our null, we need to have a pooled P hat. So this pooled P hat is going to allow us to actually test what the distribution would be if the null hypothesis were true. So that is, we want to say that our P hat pool is all of our samples together. So if we return to our previous example, we had 24 men and 30 women say that they gamble, out of a total of 45 men and 80 women, which means that our total pooled proportion is 0.432. So about 43% of all respondents answered saying that they gambled. So now we want to test to see if those things are different. To do this, we need to calculate a new standard error. So we use our SE pooled, or to calculate our SE pooled, we also need to have our P hat pool, which is what we calculated above here, and our Q hat pool. Note that because we are still asking about the difference between two values, we need to have the pool in both of these places. However, we'll divide by the n of men and the n of women. So we're going to plug our numbers in here, and we get 0.0923. I'm not going to spend too much time doing the calculation because, again, I expect that you will be using StatCrunch to take care of most of these steps for you. Now our z statistic is the same thing it's been before. We take the difference between our two values, so our p hat men minus our p hat women. So because our null is 0, all we would be doing here is subtracting 0. So our data is here minus our null, but because our null is 0, I'm saving some space on the screen. We then divide by our standard error pooled. So this 0.1583 is the same value we calculated in the section on confidence intervals, but it is just our 24 out of 45 minus 30 out of 80. So that's the difference in the proportion for men and women. We then get a z statistic of 1.66. Now remember, what we want to know is how likely it is to get that z statistic, or more extreme, by chance if the null hypothesis is true. So we want to know what is the probability of getting z of greater than or equal to 1.66. So we go to StatCrunch, we open our calculators, normal. We're going to ask for greater than 1.66. Click compute. Now I want to make a few points here. So first, our value, 0.04845, is the p-value for our one-tailed test. The second is, note that this red area is the smaller of the two regions. If, by chance, I had just left this as less than, we would see that the red covered the large chunk of the value. Now if it gives me a value of 0.95, I know that can't be correct because it's not giving me the tail of the distribution. All I want is that outer portion. So if I change that to greater than, it gives me this value back. So if we go back and plug that in here, that means our p-value, or our one-tailed p-value, is 0.043. However, because we had an alternative hypothesis of not equal to, rather than just greater, we also need to double that to get our two-tailed p-value. So that is, on StatCrunch, we need to have the red here, as well as the red for negative 1.66. So the same value here to get that tail included there because it's symmetrical. So we double our p-value to get 0.086. So almost 10% of the time we're going to get values this extreme or more extreme by chance if the null hypothesis is true. Now under our most common threshold, an alpha of 0.05, this would mean that we would fail to reject the null. This does not necessarily mean that the null is true, it just means we don't have enough evidence to say that it is untrue. Alternatively, I'm going to show you in the next video how to use StatCrunch to make this test instead.